right. Today, we're going to be talking about zeros and poles of rational functions. And so let's just review what a rational function is. So a rational function is one of the form f of x, and it's going to equal p of x over q of x. And p of x and q of x are polynomials. So the premier example of a rational function is this one right here, where f of x equals 1 over x. And a big thing that you should do whenever you encounter a rational function is you should identify the top and the bottom. What is p of x and what is q of x? In this case, p of x is 1. That's a constant polynomial. And q of x, the bottom, is equal to x. That's just a linear polynomial x. And it's good to get used to what graphs of rational functions look like. This is the graph of f of x equals 1 over x. And it's these two branches right here. And they have this asymptote, this vertical asymptote at x equals 0, and a horizontal asymptote at y equals 0. Okay, here's another example of a rational function. So x over x minus 1. First, we identify the top. The top is this p of x. It's equal to x. And the bottom is q of x. And it's equal to x minus 1. Both of these are polynomials. So this is a rational function. Okay. Now, let's talk about zeros and poles. So a zero of a rational function, where a rational function is f of x equal to a polynomial over another polynomial, is where the top equals 0. So a zero of a rational function is where the top equals 0. A pole is where the bottom equals 0. It's where the bottom polynomial equals 0. That's a pole. Okay, so let's identify the zeros and poles of this function f of x equals 1 over x. So we know that the top function is 1 and the bottom function is x. So if we wanted to find the zeros, we would set the top equal to 0. And we see that the top is 1. It's a constant. It's never equal to 0. So this whole function has no zeros. Now, if we wanted to find the poles, we would look at the bottom function, q of x. And q of x is x. So we set that equal to 0, and we see that this is 0, q of x equals 0 when x is 0. So this whole function, f of x, has a pole at x equals 0, and it does not have any zeros. Another thing that we're going to see is we're going to look at graphs of rational functions and identify zeros and poles using a graph. And the short answer is zeros correspond to where our graph crosses or touches the x-axis, and poles are going to correspond to vertical asymptotes. Okay, and here's just a little schema for you guys to find zeros and poles. So first thing, when you encounter a rational function and you're asked for the zeros and poles, you identify the top and bottom polynomials. And then to find zeros, you set the top equal to 0 and solve. And to find poles, well, I made a mistake there. You set the bottom equal to 0, and then you solve. All right. Here's an example of that. Okay, so here's another function. It's a rational function. It's f of x equals x minus 1. So the first thing we do, we identify the top and the bottom functions. So the top of our fraction is going to be our p of x, and we see that that is x. So our first top function is p of x equals x. And then our bottom function is x minus 1, and that'll be q of x. And we'll have q of x equals x minus 1. So we set the top function equal to 0, so p of x is x, and then we set x equal to 0, and we see that x equals 0 is our 0. And then we go to our bottom function. That's our only 0 for the top function. The bottom function is going to correspond to our poles. Where this bottom function is equal to 0 corresponds to our poles. So we know our bottom function is x minus 1, and we set that equal to 0. So we set x minus 1 equal to 0, and then we solve. The way we would solve is we add 1 to both sides of the equation, and we get that x equals 1 is a pole. And here's one similar to what you'll have in your homework. So this problem asks you to find the zeros and poles given the following graph. So this is the graph of our rational function. And so the thing that you should note is zeros on a graph are where it crosses slash touches the x-axis. And then poles, what do they correspond to? Well, they're going to correspond to vertical asymptotes. All right, and so let's look at this graph right here. I'm going to change the color, and let's identify our zeros. So let's see where this function, the graph of this function, crosses the x-axis. So this is the x-axis, this is the y-axis. And let's look, let's scan across. I'm going to start from the left and scan across. So I'm scanning, 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 and oh, at x equals -6, I see that we cross the x-axis. I keep scanning. Oh, at x equals -2, at x equals 2, and at x equals 4, we have zeros. So our zeros are going to be x equals -6, -2, 2, and 4. And then let's try and identify where our vertical asymptotes are. So it looks like we have these branches here that kind of approach this line right here. And they kind of approach this line right here. I'm doing it dashed to represent that these are asymptotes. And it looks like they cross the x-axis at 3 and -3. That will be where our holes are. And our holes will be x equals -3 and 3. And that's all I have for stuff about rational functions. Thanks for listening.